Hey everyone, this is Mr. Wyrick, and I'm here to go over the second part of the 4.1 notes for you. Just a couple of quick things. Number one, if you are a freshman, you should be watching this on Thursday because you should be on Tuesday taking the English 1 end of course exam, and I hope you either do well or that you did well and you don't have to worry about that anymore. On Thursday, the sophomores will be taking the English 2 exam. So freshmen, you'll have a chance to work on this. So it kind of flip-flops around Tuesday and Thursday, and we'll be able to kind of work through that. I'll talk to you, of course, in class on Wednesday, and we'll see how things go. So again, what we were already talking about was shear transformations, where you hold on to a certain line through a two-dimensional object and flip everything else that was on that line somewhere else. So we create a parallelogram from a rectangle, or we create a different triangle from a triangle that we had. And because we're using the same amount of space, we're cutting off something over here and putting it somewhere else, we end up with the same area. This is actually one of the tenets of Cavalieris principle, which is why it's part of the name of the notes. So we have Cavalieris principle, and it's being created by these shear transformations. So as we look at day 2, we have this definition. You need to take this down in your notes. You need to try to understand it as much as you possibly can, and that's Cavalieris principle. If two figures in the plane have congruent bases, equal heights, and cross-sectional line segments parallel to the base that are equal, then the figures have equal areas. So we're talking about we have the same base, all those figures yesterday that had the exact same base. We have the same height, so we're looking at the same height, and it's the same figure, okay? We can't say that, oh, we have a rectangle with a base of 4 and a height of 5, and then we have a triangle with a base of 4 and a height of 5 and be like, they should be the same. That's why we have that other part in here where we have the cross-sectional line segments that are parallel to the base, the horizontal lines that we were drawing in earlier. And the example that's on this page for the start of day 2 has those horizontal lines drawn in on it as well. So even though we're looking at two triangles, they could be completely different shapes, and it might not be a shape that we have a name for. But if we're able to find that relative shape that's going to have the same cross-sectional lines, same base, same height, then we're able to apply Cavalieris principle and say, hey, I calculated the area on this one. I know the area of the other one. If we look at the next slide, which should be slide number 9, there's some interesting things on here. We have a circle, and we have what's known in mathematics as an ellipse. You might be thinking of it as an oval, but I would say this is more than likely an ellipse, just based on the look of it. And sure enough, we have the same radius there, which is like a base for a circle, and we have that height that's the same. So even though we can't really calculate the area of that one without knowing some other stuff, if we can compare it to the circle, we should know the circle has the same. The next one's very, very interesting. We have a base of a single point. We have a cross-sectional line that would have the same distance. So the circle and that, I have nothing else to describe that shape other than a capital D. Those would have the same area. And the last picture, I had to rotate it to fit it on there. It's one that's a pretty extreme example, but the inner concentric circles are congruent to what we're looking at down here on this triangle on the bottom for those horizontal lines. So it's very interesting with Cavalieris principle how you can apply some of those some of the things from it and find out the same shape. Our day 2 assignment should say handout 4.1c. It is, of course, going on next 6 weeks. End of the 6 weeks is Friday. I really need anything in paper on Wednesday, so make sure you get that to me, and we'll see everybody at testing and in class, and it'll be great to be back at school with you.